the SpaceX Starship lander touches down on the surface, ejecting a plume blast of high-energy particles in all directions. It carries rovers and vital construction equipment for an entirely robotic mission to build a lunar landing and launch pad. A team of specialized rovers, equipped with path-clearing equipment, navigate the uneven terrain, clearing paths and preparing construction and operation sites. Simultaneously, a self-expanding shelter is assembled to provide protection against the rocket's ballistic dust plume and thermal threats. Cargo rovers shuttle back and forth, unloading supplies at the newly erected storage shelter. The terrain preparation team completes their task successfully, preparing 2 locations, one for power and another for communication systems, then return to the rover shelter. In the next setup phase, a rover transports a mobile kilo-power reactor to the power site, while another rover delivers a communications tower to the communications site. A robot team consisting of a trencher, cable layer, and bulldozer lays electrical cables from the storage site to the power and communications sites. A rover with a robotic arm connects the cables to their respective devices, ensuring a reliable power supply prior to the impending Starship departure. As the rovers safely retreat to the protective shelter, the Starship takes off for its return mission to Earth. For augmented power, towing rovers position self-deployable solar units near the kilo-power reactor. A precision robotic arm connects these solar units to the existing power grid that had been established prior to launch, fortifying the power system with additional sources of solar power during the lunar day. With the additional energy infrastructure deployed, a rover clears routes to the regolith sorting and excavation tailing sites for efficient transportation routes. The Energy Infrastructure robot team establishes new power connections to the regolith sorting machine for regolith sorting and feedstock operations. A swarm of bulldozer rovers flatten and prepare a lunar landing pad construction site, while specialized rovers position themselves at locations for moving process, regolith, and tailings, poised for the upcoming excavation work. As the mission progresses, excavators spring into action, removing dirt and carving out landing pad berms by digging 3 meters down to create a level landing platform. Systematically unloading their hull into specialized haulers, the excavators work in tandem with them to transport the dirt to sorting facilities or overfill spoil piles for organized management of the retrieved materials to create the feedstock needed for the brickmaking process. With seamless coordination, haulers deliver regolith to the sorting stations and spoil piles, maintaining a steady workflow. As the excavation concludes, the rovers retreat to their shelters, while a swarm of specialized brick bots called Lunatrons emerge. These robots skillfully convert the processed regolith into bricks to precisely lay them on the prepared and leveled surface, creating a paved and finished landing pad after placement of navigation beacons. As the pad's pavement construction approaches its end, berm building machines are brought in to begin placing a protective outer covering against the excavated berm walls by filling specially designed bags with regolith to create rego packs, built to withstand the harsh plume blast from the rocket engines. These carefully positioned bags reinforce the berm walls, ensuring additional protection against potential explosions or from the powerful impact of debris generated by the roaring engines of future missions to the lunar South Pole. The landing pad's realization marks a milestone where human aspirations converge with the precision of robotics, heralding in a new era of lunar exploration.